Section 2.2 subsets. This section we will cover four objectives. The first one, to recognize subsets and use the notation. Number two, to recognize proper subsets and use the notation. Number three, to determine the number of subsets of a set. The last one, to apply concept of subsets and equivalent sets to infinite sets. Set A is a subset of set B if every element in set A is also an element in set B. Or we use a notation as A represent the set A, B represent the set B. A is a subset of set B with the notation looks like the letter U sideways with the line underneath. If we cross it in the middle of this notation, it means A is not a subset of set B. A is not a subset of set B if there is at least one element or one member of set A that is not an element of set B. And we can say every set is a subset of itself because every element of the set A is also an element in set A itself. The proper subset. Set A is a proper subset of set B if set A is a subset of set B and set A and B are not equal. Or we can say the set A has less number of members than set B, and we use a notation as A represent a set A, B represent a set B with the notation like the letter U but no line underneath. That means A is not equal to set B, but all elements in A also element in B. The symbol for the subset, we use the letter U sideways and the line underneath. If you compare about the set of the numbers, it's similar to the inequality symbol as a less than or equal to. That means the number can be the same or less than. For the proper subset symbol, it's just a letter U, no line underneath. And that is similar to the inequality symbol for the strictly less than. That means the number on the left must be strictly less than the number on the right. For this example, we're gonna write the notation for set, subset, and the proper subset. So I'm gonna put a note here. So this one for subset in general, and this symbol is for proper subset. So that means the set on the left of this symbol must be smaller than the set on the right side of this symbol or this notation. Okay, for example A, the set on the left contains number 1, 2, and 3. The set on the right contains 1, 2, 3, and 4. Let's check term by term. 1 here, also 1 in there, 2, and also 2 here, 3, and also 3 here. That means the left-hand side set is the subset of the right-hand side set. And also the left-hand side is the proper subset of the right-hand side because every element, every member of the left set is also the element of the right set. And at the same time, the left set is smaller than the right set. So both subset and proper subset. For this case. And then example B, the left-hand side set contains 3, 7, and 1. The right-hand side set has 1, 3, 7. Even though they are not in the same order, but they both have exactly the same set of the numbers. We can say the left-hand side is subset. So we put the notation for the subset or the U sideways with the line underneath. We can say only the subset notation that we can put in here. And we put the note not proper subset because the left-hand side is exactly the same as the right-hand side. It's not smaller than the right-hand side set. Example 2. Determine whether the following statements are true or false. If false, what would make the statement true? For part A, we have the number 7 and the notation to represent the proper subset and the right-hand side as a set. So make a note here. 7 is an element or the member, and the right-hand side is a set. The notation that we use here is not appropriate. So we can say this is false. The good statement or the true statement of this should be 7 is the member of the set of 1, 3, 7, and 8. For part B, the number 0 on the left and the notation on the right is the notation of the empty set. This one means 0 is a member of an empty set, which is not true. So the correct one, it should be 0 is not the member of an empty set. Part C, MD is the member of the set that contains MD, ME, and MO. The left-hand side is the member, which is one of the member containing in the set on the right-hand side, and the notation that we use in this problem is appropriate as the notation for the member. Then part C is true statement. Part D, the left-hand side set contains 8, 9, and 10, where the right-hand side set has the same set of the numbers, 8, 9, 10. They are the same, or both left and right sets are equal. Therefore, we can use the subset symbol, and this problem we can say this statement is true. We can say this subset. And then part E, the set on the left has 8 and 10. The set on the right has 7, 8, 9, and 10. 8, 10 also, both of them also are contained in the set on the right hand side. And the notation that we use to represent the set on the left is the subset of the set on the right hand side. This is another true statement. And this one can also be true. For the statement, the set that containing 8 and 10 is a proper subset of the set containing 7, 8, 9, 10 because the left-hand side set is smaller than the right-hand side set. Subset and the empty set. The empty set, as we have seen before, with the notation either the 0 with the crossbar or the open and then closed set symbol. For any set B, the empty set is a subset of the set B. For any set B other than the empty set, we can say the empty set is a proper subset of set B. Because with the assumption here, that means B is not an empty set. Therefore, there is at least one member. One member in set B, and that makes set B not empty. If it's not empty, so that means it has more members than the empty set itself, because this one is the empty set.